Okay, so this example is the application for the exponential growth in population. The size of the raccoon population at a national park increases at a rate of 4.3% per year. If the size of the current population is 157, find how many raccoons there should be in 4 years using the function f of t equals 150 times e to the 0.4043 times t, and round to the nearest whole number. Okay, so this would be the population growth model. Okay, so you see the base is e. Okay, it's e. So now let's look at in 4 years. So 4 years, so t equals 4, so that means t equals 4, right? T equals 4. The population at t equals 4 is f of 4. We plug in 4, 157 times e to the 0.043. This is the percent, 4.3%, right, times t. T is 4, sorry, so we should plug in 4 times 4, okay? And we do the calculation. So 157 times e to the what? So this is the 2, 6, 1, so it's 3 decimals, so it's the 0.162, right? Sorry, 172. So we use a calculator. The first thing we needed to do is to do the calculation for this number. Okay, so this would be e to the 0.172. Okay, so the first thing you should know is how to find the e functions in your calculator. Okay, so you will get this number, which is times 1.187677833. Okay, so don't round this number, okay? Keep as many decimals as possible. Then we do the calculation times 100, this number times 157 times 157. So you will get 186.465419.8. Okay, so your final answer will be nearest whole number. So this would be, this is less than 5, so it should be 186 raccoons. So this is the example for the exponential growth in population. So next we want to learn which is called compound interest. Okay, compound interest. So we want to use the formula to calculate the compound interest. So the formula for the compound interest is given by A times A equals P times 1 plus R over M times to the M times T. So this is the compound interest. So I will explain each letter. So here P is called principal. P is called a principal, which is the present value. Which will be invested, okay, present value. So we will invest this amount of money. And R is the rate, okay, interest rate. In general, it would be a percentage, but we need to use the decimal form, okay? R is the rate. M means we need a compound M times per year. Compound M times per year. Okay, so at the end of each period, the interest will be calculated and added to your original principal to get a new principal. Then you continue this way. At the second period, then you have a new interest based on the new principal, right? Then add this new interest to the previous principal to get another principal and continue. Okay, so here is some words which is called compound monthly. So that means we will calculate the interest 12 times per year. So M equals 12. If you see the compound yearly, so that means you just calculate the interest one time per year. So M equals 1. If you see the compound quarterly, so that means every 3 months you will calculate, the interest will be calculated. So M equals 4. Compound semi-annually, so that means every half year you will calculate the interest. So is 2. Okay, so here T is in years. Okay, how many years you want to invest this amount of money? T is the years. Years for for the investment. Okay, and A is the future after T years. What is the money you will have? How much you will have? This is called future value, future money, or the future value. A is the future value. Okay. So this is the one formula which is called compound interest. We have another formula which is called continuous compound interest. Continuous compound interest. So that means the frequency of the compounding is increased infinitely, so that at every instant in time, interest will be calculated and added. Okay, so the interest will be calculated at any time, every instant in time, and then be added to the principal. So this is called continuous compound interest. Okay, and so the formula is A is the future value, P is the principal, the present value, times E is the base E, right? It's about 2.7, to the R is the interest rate in decimals, times T. T is years. Okay. So now we want to use these two formulas to calculate some problems. So in this example, we want to find the accumulated value of an investment of $10,000 at the interest rate 4% compounded semi-annually for 5 years. So this is we use which formula we should use. We use the first or the second. We should use the first formula, right? We should use this formula. This formula, okay? So now, not the continuous compound interest, but this one. Okay. So I write down the formula. This is A equals P times 1 plus R over M to the M times T, right? So the accumulated value, which is the future value. So we want to know A, right? So P here, P is the present value, which is $10,000. So it's 10,000. And the rate R, the annual rate, which is 4%. 4% means we need to write as a decimals. It should be 0.04. And the compound semi-annually, I just say the semi-annually means M equals 2. And the T, 5 for 5 years, so T equals 5. So we have everything, right? So the next thing, we just need to plug in the numbers. So the future value A is equal to 10,000 times 1 plus 0.04 over 2. Then M times T, M is 2 times T is 5. Okay. Of course, you can do the calculation. You just input these numbers directly into a calculator, then you can get your final answer. But this is just for the students who are familiar with your calculator. If you're not very familiar with your calculator, just do it step by step. Let me do it step by step. Okay. So this is the 10,000 times 1 plus. So what is 0.04 divided by 2? It's 0.02, right? Then to the power 2 times 5. 2 times 5 equals 10. Then we add this one. Let's look at the base for this exponential. Exponent for the exponential. The base, okay, so this is the 1.02 to the 10. Okay, so now we use your calculator. You can use your calculator to do the calculation for this power. So this is the 1.02 to the power 10. So this would be 1.21899442. Okay. So this is then you multiply by 10,000. Then you will have 12189.9442 dollars. But in general, we will keep for the money, we will keep 2 decimals because we use the cents, right? We should include the cents. So this would be 2 decimals. So this would be 12189.94 dollars. Okay. So keep as many decimals as possible. Otherwise, you will have some errors on your final answer. Okay.